All right, moving on to section 4.2, notes about measuring segments. The objectives for this lesson is that you should be able to find the length of segments using segment addition, and then you should be able to find the length of segments using congruent segments. Start with a little vocabulary. Again, reviewing from what we talked about in 4.1, what is a segment? It is a part of a line that has defined endpoints. Remember, lines go on infinitely in both directions, while a segment is a part of a line that has a beginning point and an end point. Measuring segments. It is the distance from one endpoint to another. And another way that you can find the measurement of a segment is by adding the segments that make up that bigger segment. For example, we want to find the measurement or the length of A to B. So if we look at the number line where we see points A and B, right, if we ignore the fact that point A and point B are on the negative parts of that number line, and we see that the distance from A to B is made up of 3 smaller segments. Right? Each of those segments is exactly 1 unit long. So we can talk about the length of A to B being the sum of those 3 segments together. And since each of those segments is 1 unit long, that means the total distance from A to B is 3. Right? You can say the same thing about B to C. From B to C, we see that it is made up of 3 smaller segments, each of them measuring 1 unit long. So the length from B to C is also 3. We can talk about from C to E. C to E, you can look at it as the addition of C to D plus DE. Distance from C to D is 2 units. The distance from D to E is also 2 units. So therefore, the length of CE is 4. So that leads us to the segment addition postulate. The segment addition postulate goes like this, that you can have the bigger segment. In this case, in this picture, AC is the biggest segment. And you can talk about the length of AC as being the sum of 2 smaller segments, segment AB plus segment BC. Adding those 2 smaller segments together, the sum equals the length of the bigger segment, AC. Let's apply that postulate to example number 1. It says to find the length of segment XY. And looking at the picture, we see that the biggest segment there, XY, is the sum of 2 smaller segments, XZ and ZY. Right? So those are the 2 smaller segments that we can add together to make the biggest segment on the picture, XY. So now to find the length of XY, we're going to substitute the lengths that we know for the 2 smaller segments. XZ is given to be 7. ZY is given to be a length of 9. Thus, that gives us XY to have a length of 16. Let's take a look at example number 2. Here we're trying to find the length of XY again. However, you notice that XY this time is not the longest segment in the picture. The longest segment in the picture appears to be segment ZY. Okay, so how we're going to use segment addition postulate for this one? Well, we're still going to set it up as we did with the previous example. We're going to have the biggest segment in the picture. That would be segment ZY. And we're going to set it equal to the sum of the two smaller segments in the picture. That would be ZX and XY. Right, so we have the biggest segment in the picture, ZY, equal to the sum of the two smaller ones. So now let's go ahead and plug in the information we know. We know that ZY has a length of 12. And we also know that ZX has a length of 5. But we don't know the length of XY. Okay, so we're setting it up where we can use our algebra skills to find the length of XY. Here, the length of XY is equal to 7. Now, I know most of you probably figured that out already without having to go through all these steps. But it's very important for this particular unit that we follow the protocols as I am demonstrating and modeling for you here. And we're going to keep talking about this throughout the many examples throughout this unit. It's very important that you are practicing this and know this for the quizzes and tests. So let's see how we can use segment addition postulate to set up an equation for example number 3. We're going to start with the biggest segment in the picture. That is segment AB. And then on the other side of the equal sign, we are going to add up the two smaller segments that make up AB. That would be AC plus CB. This is the initial setup that you want to be able to write down, again, for homework problems, quizzes, and tests. Now we're going to go ahead and plug in the given information. We know that AB is 36. We know that AC is 6. And that CB is the expression 2x plus 10. So after subbing those in, as you can see, we have an equation which we can solve for x. And we get x is equal to 10. Okay, let's move on to example number 4. Here we're given the length of BC is equal to 25. And we want to find the length of AB and AC. So let's start off by writing the given information. We're given that BC is equal to 25. But we also see that BC has an expression 7x minus 3 associated with it. So we're going to plug that in for BC. And this is going to give us an equation where we can solve for x. All right, so we got x is equal to 4. Now to find AB, we see that there's an expression associated with AB, and that's x plus 2. So we're going to write AB is equal to x plus 2 to start. All right, because we solved for x and got x to be 4, we plug 4 in for x, and we got AB equal to 6. Now we need to find the length of AC. By using segment addition postulate, we can say that AC is equal to AB plus BC. So we're going to write that down first, and then we're going to use a little substitution. Since we just figured out that AB is equal to 6, and we're given that BC is equal to 25, we substitute those in, and we get the length of AC to be 31. All right, moving on to the next vocabulary phrase here is congruent segments. Congruent segments are segments that have the same length. Now, if you look at example number 6, you notice that this diagram has several different markings on it. These markings are called tick marks. These tick marks tell you which segments are congruent in the picture. All you have to do is match up the different markings. Like, for example, you see that each of these line segments here that I highlighted has that single line like a dash. Because they are the same marks, they are telling us that these two segments are congruent. And this is how you write that statement. Segment AB is congruent to segment CE. Again, the symbol for congruent is that equal sign with that tilde mark above it. These two segments have like a double dash tick mark. So that's telling us that these two segments are congruent. Segment AD is congruent to segment DC. Tick marks don't always have to be lines or dashes. They can be any sort of marking, like these circles. These circle tick marks are telling us that these two segments are congruent. Segment BD is congruent to segment DE. Okay, let's finish up with example number 7. We're given that segment PQ is congruent to segment RS. So looking at the picture, we want to solve for X. All right, so we're going to say that segment PQ is congruent to segment RS. So that means that these two have the same measurements. So let's sub in the measurement of PQ. We see PQ is made up of two smaller segments, one measuring 8, the other one measuring X. Put an equal sign, and then we're going to sub in the measurement of RS. Again, RS is made up of two smaller segments, one of them measuring 15 and the other one measuring 6. So after those substitutions, here's an equation that we can use to solve for X. And we get X is equal to 13. Okay, so that's it for this lesson today. Move on to the 4-2 homework.